Hello dear students, in this lesson we are going to learn about significant figures and estimation. Let's take an example. Let us imagine there are two cities and you have to guess the approximate distance between those two cities. The actual value is around 4,123 kilometers, but you may need to just guess it to the nearest thousands. So yeah, it's about 4,000 kilometers roughly. So students, what is significant figure? Significant figure is a kind of number of digits in certain measurement that simply decides the accuracy or precision of that measurement. Now that depends upon different situation at what level of accuracy we want that measurement. So those kind of numbers are called significant. So basically those numbers are very important in that particular measurement. Basically that decides the overall structure of that number or overall worth of that number. So those digits are called significant figures. Now let's take an example. There are certain numbers. The first number has just one significant figure. It's shown over here. The second number has just two significant figures. So you guys must be thinking, zeros are always insignificant or not significant? Students, sometimes zeros are significant and sometimes not, and that's what we'll be learning in upcoming examples. So there are some basic rules for whole numbers, students. Whenever we have a whole number and that has either leading zeros or trailing zeros, they are always insignificant. We do not consider them as significant. So look at these numbers. It's 0 here, and these zeros are basically not significant. Whereas if you talk about the decimal numbers, we again have different rules and regulations. So what we can do, we can discuss rules one by one, and then after we can practice a few questions. So first of all, if you have a number which is made up of non-zero digits, means the numbers are other than 0, they are always significant. Just like this example, this number has 4 digits in that, including the decimal number as well as the whole number. So just because the numbers don't this particular number doesn't have any 0 in that, it means all the 4 digits are non-zero numbers, non-zero digits. Therefore all of them are significant. This number has just 2 digits and which are again non-zero. Therefore, there are 2 significant figures in that number. Now let's take the second case where we have zeros, but these zeros lie between any 2 non-zero digits. So in that situation, along with those non-zero numbers, these zeros are also considered to be significant. Just like here we have 6 digits in that number. However, there are 2 zeros and there are 4 non-zeros, but just because they lie between 2, there are 2 non-zero numbers between which they lie. Therefore, these zeros are also considered to be significant. Same thing happens here. We have 4 digits in that. Again, 2 are zeros and 2 are non-zeros. But just because zeros occur between 2 non-zero digits, therefore, these zeros are also considered to be significant along with non-zero numbers. Now the third rule is, students, whenever we have a decimal number and we have leading zeros, no matter whether they come before the decimal or after the decimal, but if they don't have any non-zero number before that, so these kind of leading zeros are not significant. So in the first number we have just one significant figure, despite of different zeros present as leading zeros. Even here we have just 2 significant figures, no matter there are several zeros present at the beginning. So these leading zeros are not significant. Now the next rule is when numbers, now students, there is sometimes students might have some misconception when we have a decimal number and sometimes when we have a whole number. Let's say we have a whole number. So I already told you, students, in whole number, trailing zeros are not significant. What I said, trailing zeros are not significant. So in that particular whole number, there exists only one significant figure. But students, if it's a decimal number, the rule changes. Even after the decimal, we have these trailing zeros, but they are considered to be significant. So there are three significant figures. That is where it's a kind of exception you can understand. Just remember that in whole number, trailing zeros are not significant, whereas in decimals, trailing zeros are significant. It will be clear to you when I show you examples. Then you will realize in whole numbers why these trailing zeros are not significant. And these are a couple of examples, students, and you can simply notice how many significant figures are there in that numbers. So this is a kind of summary of all the rules that we discussed. There is one more example, students. You can also learn, I can just recall all the rules here. Just like leading zeros are not significant. If it's a decimal number, then trailing zeros are significant, and non-zero numbers are always significant. And if zeros occur between two non-zero numbers, they are still significant. Okay students, now we need to learn how do we round off significant figures. We need to follow the same rules that we learned earlier in rounding numbers, whether it was a whole number or decimal number. So here we'll have to first of all identify to which level, means to which digit we need to round it off. Sometimes question might ask you to round the number to 2 significant figure or 3 significant figure. Now you guys already have an idea how many significant figures and when to consider a number or a digit to be significant or not. And students, the rules are similar, just like we did earlier. First of all, you need to decide a target digit, and the number which is next to the target digit, if that is greater than 5 or equal to 5, we have to add 1 to the previous number. That's called the rounding up. Otherwise, if it's the number which is next to the target digit, if it's either 4 or less than 4, we don't have to add anything to the target digit. We'll have a couple of examples. In this question, we need to round this number to 3 significant figures. Let's rewrite the number first. And students, as I told, in whole numbers, the trailing zeros are not significant. So we can use that concept. First of all, question said we need to round this number to just 3 significant figures. It means the third digit from the beginning is the target digit. So what you do, you round it up because the next number after 3 is 8, which is greater than 5. So it becomes 4 as we add 1 to that number, and the leading digits are kept as it is. But students, now just because if you notice, if we only write 264, we cannot compare it with the original number because that's too small in comparison to the initial number. So to overcome that situation, students, we need to replace these numbers by 0, just like we used to do in roundings. And this is how you know that trailing zeros are not significant, and however the 3 non-zero numbers are still significant. So we have 3 significant figures, and this is how we have made our number simpler than earlier. Earlier we had multiple digits to handle, but right now we just have 3 initial digits to handle, so that's why it's rounded to 3 significant figures. Let's take the next example. This time we have a decimal number, students. So in decimal also, students, we have leading zeros to be insignificant, they are not significant. However, if 0 occur between 2 non-zero numbers, that's still significant. So we need to consider 4 significant figures, students. So we need to count, we have to first of all leave these leading zeros because these are obviously non-significant. So from the beginning 1, 2, 3, 4 means this later 2 is our target digit. And the number which is after that, we need to leave it. We have to replace it by 0. Okay students, now there's a catch. Just because it's a kind of decimal number, so as I told you, trailing zeros are even significant in our decimal numbers. So though we have to leave that number, but we cannot add a 0 at that place, just because we know that in decimals, trailing zeros are not significant. So it means that we need to remove this number, as 2 is my target digit. This 2 is the target digit, and we will follow the same rules that we'll have to add 1 to the previous number, as this next number is greater than 5. So it becomes 3 and the remaining numbers remain as it is. But we are not going to add 0 at the place where we have removed 9, just because if we add a 0, it will be counted as a significant figure, and we don't want that in decimal. So remember, if we have a whole number, we have to add a 0. We need to replace the missing digit by 0. But if it's a decimal number, we don't replace 0 at that place where the number is being removed. We simply leave the number, because if we add a 0 here in that case, it will be considered as significant. That's why we do not add any 0 while removing the decimal figure. But definitely when we remove the whole number, when we remove any whole digit from the back, we do have to add a 0 at that place. Right now you can count there are 6 digits in that number. However, there are 2 leading zeros which are not significant, but there exists another 0 between 2 non-zero numbers. It's still significant. So total there are 4 significant figures. So we can simply choose the option. This option is correct. Let's take the next example. This says round to 1 significant figure. It's a good question. So now students, we can utilize both the concepts that we used in the previous question and even before that. First of all, we have 78.5. Students, the target digit is the first one only because question says to round to the 1 significant figure. So we need to remove the later digits from here. And students, as I told you, when we have to remove, okay, first thing you need to just check whether the number which is next to 7 is greater than 5 or not. Yes, it's greater than that, greater than 5. So first of all, we add 1 to the previous, that is the target digit. That becomes 8. Now students, as we remove this 5, as I told you, while removing the decimal figure, we don't have to add a 0 because then it will become significant. So we don't want this to be significant, so we don't have to replace a 0 over there. However, if we don't write 0 for the whole digit, this won't be around approximately equal to that. It will be very less number. So we do want to add a 0 at the place where we are leaving a whole number, but we do not add any 0 at the place where we have left the decimal figure. So yes, we have removed this 8 and we replace it by 0. And it makes sense. 78.5 is approximately equal to 80. So that's your answer. Let's quickly have one more example. This time question says round to 3 significant figure. Again, this will actually be more easier to understand in that question. First of all, let's rewrite the number, and then we need to identify the target digit. We want 3 significant figures, so from the beginning itself we can count, and we want to stop here, and we need to just first of all check what is the next number after 3, which is 8, and so we have to add 1 to this target digit. That becomes 4. And now students, as you know that if we have to remove these decimal numbers, we don't have to add any 0 at that place, because if I add a 0, it will become significant. I don't want that. However, if I have to remove these whole digits, we do have to add a 0 because they are not considered to be significant, and that will maintain the approximate value of my original number. It was around 27,384. It's still around 27,400 something. So if we don't add a 0, then again there will be a trouble. We don't want that number to be lesser. We just want to make it simpler. We do not want to change it drastically. So the answer is going to be 274,000. And right now you notice there are 3 non-zero numbers which are significant. These trailing zeros in the whole number are not significant. And we are done. This is how we round a certain number to certain significant figures, students. After that, we need to learn estimation. Again, estimation is used to make the calculation simpler. Sometimes we may have complex numbers and we don't really all the time want the exact answer. Even approximate answer might work in certain cases. So in that scenario, we perform estimation, and we do it by considering numbers to certain significant figure. Mostly we consider we round the numbers to one significant figure, and we perform calculation. And we often use this symbol, which is approximately equal. The exact two lines are basically exactly equal, but when we draw this kind of wavy equal sign, that simply means it's approximately equal. So these are a couple of rules that we'll be discussing and in the questions. That first of all, you need to round the number correct to one significant figure, and then we can use this kind of approximately equal sign, and after that we can perform calculations. Let's continue with an example for now. Look at the example, and first of all, students, we want to write their estimated values, so correct to one significant figure. So 6.9 is approximately equal to, as we round to one significant figure, means at 6 we need to stop and we need to leave other numbers, or we can replace 0. Just because it's a decimal number, students, so we have to leave the number as it is. We don't have to add a 0 at that place. And just because this next number is greater than 5, so we have to add 1 to that number. So 7 is the approximate, 7 is approximately equal to 6.9, and it's just one significant figure. Similarly, 96 can be again rounded to one significant figure. So 9 is your target digit, and just because this is a whole number of students, so you do have to add 1 to the previous number. Like we have to add a 0 at the place where we are leaving the number. So 6 we remove and we get a 0 at that place. When we add 1 to this 9, because it's greater than 5, it becomes 10. So students, there are 3 digits, but still there exists only one significant figure only, and that's too simple to multiply, that is 700. So this is how we can estimate this product. Rather than performing the entire multiplication accurately, we had to just estimate that, and we can easily handle these simpler values and we can multiply and estimate them. Let's take an example where we have a word problem. So question says Brian buys 197 packets of crisps for a party. Each pack cost 45p. Use estimations to find the approximate cost in pounds. So students, basically we have to multiply these two values. It's a logical question that he buys 197 packets and each packet costs that much amount, so we simply have to perform multiplication. And again, students, just because we need to estimate the cost, what we do, we have to first of all round these numbers correct to one significant figure. So in that, again, this is my target digit, and students, just because it's a whole number, so we need to first of all add zeros at the place where we are leaving the numbers, and just because next number is greater than 5, we add 1 to the previous number, so it's approximately equal to 200. Similarly, we can round 45 correct to one significant figure. We need to leave this 5 and we replace it by 0, and again we still have to add 1 to this number so that it follows the rules that we discussed. So approximately, students, we have got 200 times 50. That's easier to solve. 5 times 2 is 10, followed by these 3 zeros. So this is how we get 10,000 p's, or you can divide it by 100. That becomes 10 in pounds. So we get 10,000 divided by 100. 2 zeros get cancelled. We simply get 100 pounds as the answer. So it's approximately equal to 100 pounds. Simple. Let's continue with the next question, where we have multiple multiple operations. First, we can still do the same thing. First of all, we need to round the numbers to the nearest single significant figure. So 42, now 42, if we suppose we have a 42 students, we need to round this to one significant figure. So we have to remove this 2, but we replace it by 0. And just because this time this is not neither 5 nor greater than 5, it's just less than 5. So we simply leave it as it is. We do not add anything to the previous number. It remains 4. So first number is 40. The second number we can round. It's 389. So again we need to leave these two numbers. They become 0. And now students, this number next to the target digit is greater than 5. So we add 1 to that number. It becomes 400. Similarly students, 81 can be rounded to single or one significant figure. We need to leave this number and we can just write 8 as it is because this number next to 8 is less than 5. We got 80. Now we can perform simplification. 0 and 0 got cancelled. 4 get cancelled with 8. 4 times 2 is 8 and 400 over 2 is basically this value, this expression is approximately equal to 200. And that's how we have estimated that. Let's take one more example where we have to perform calculation using BIDMAS or BODMAS, whatever you say. We still have to follow the same rule, students. First of all, we need to round these numbers correct to one significant figure. Now this time, students, you have to be careful that we have a decimal number. So while you remove these numbers, students, which are after decimal, you are not supposed to add any 0 here, because if you add zeros here, they will be considered to be significant and we don't want them to be significant. Okay, and we can add, we do not have to add anything to this 9 because after that we have a 0 which is less than 5. So we simply got 9 point, or just say 9. It doesn't make any sense here, right? The first number we got is 9. Second number we can further round correct to one significant figure, means this is my target digit. So okay students, now here we do not have to add any zeros, but just because 9 is a whole number, we do have to add a 0 at that place, and just because it's greater than 5, we add 1 to the previous number. So that becomes 20. We got 20. Similarly students, we can round 2.99. It becomes 2.99. Again, these two decimal digits can be left as it is without adding a 0 here, but just because this is greater than 5, so we have to add 1 to the previous number. That becomes 3. 3 point, that doesn't make sense, just 3 you would say. And finally we have 5.03. You have to again leave them as it is because these are the part of decimal portion, and then after 5 won't be added by anything because the number next to that is less than 5. So we got 5 here in subtraction. Now it's much easier students. Now according to BIDMAS principle, you have to perform multiplication over addition and subtraction. So keep added and subtracted term as it is. Now you have to follow multiplication first. That simply becomes 60, and now you can go left to right. 9 plus 60 is 69. Negative 5 is gonna be 64. The 64 is approximate answer for the given expression. There is one more question, students. We have a word problem. It says estimate how many toys can costing that much money can be bought for this much price. Okay, so we first of all try to round these numbers correct to one significant figure. We want to remove 4 and 8. That's okay, we don't add anything to that, but we need to write one significant figure, so it remains 8 only because 4 is less than 5, so we do not add anything to that 8. Here 425, we again want to get we want to round to the nearest one significant figure. We have to leave these numbers, but we do add zeros this time. Why? Because it's a whole number, students, and just because the next number here is less than 5, we don't add anything to that target digit. It becomes 400. Now by just logic you can see that if you have total 400 pounds with you and each toy cost 8 pounds, how many toys can you buy? So number of toys that can be bought by that money is basically 400 divided by 8. So approximately that's gonna be 50. So there are approximately 50 toys that you can buy with this much money. Okay students, I hope this significant figure and estimation is clear to you. That's it for today. See you in the next lesson.